This is 114, and we're going to take a look at the Cartesian coordinate plane. So in this lesson, you're going to be able to understand the elements of the coordinate plane and understand the x and y intercepts. To help us understand this class better, we have to combine elements of algebra and geometry. We'll start with the Cartesian plane. Now imagine we have two real number lines, and they're crossing at a right angle. So this needs to be 90 degrees and at 0. And so where they're crossing here, that's going to be 0, 0. So the horizontal axis, we are going to call this the x-axis. And then the vertical number line, we're going to call that the y-axis. Now, having two number lines allows us to be able to determine the position of points on a graph. So let's consider point P. To be able to draw the point, imagine having to draw a horizontal and a vertical line to figure out what that value would be. So I had to travel some distance moving over to here and some distance down to get to that P. And so when we would describe the order, we're going to describe it as a pair x, comma, y. So it's the x value, comma, the y value. And in this example, that ordered pair is going to be 2, negative 4. Now when we speak of the Cartesian plane, we mean the set of all possible ordered pairs x, y. So we're looking at it through that the abstract lens. Now here's a summary about the important facts when it comes to this Cartesian plane. The first is if I have 2 points, A and B, and the next point, C and D, they represent the same point if A equals C, which is like saying the two x values equal each other, and B equals D, which is saying the two y values equal each other. So if A equals C, the two x values, and B equals D. It's kind of like common sense, but there's a reason why we're doing this. You're going to see it later on in this class. Now, if the point xy lies on the x-axis, if and only if y is 0. And if that happens, we call it the x-intercept. Now, if x and y lies on the y-axis, if and only if x equals 0, we call that the y-intercept. So wherever it crosses the axes, if the point crosses the x-axis, we call that the x-intercept. If the point crosses the y-axis, we call that the y-intercept. And it's going to be important because you're going to see later on in this class, we assume the y is 0, so y equals 0 along the x-intercept, or the x-axis for the x-intercept, and we know that x equals 0 along the y-axis for the y-intercept. And then the origin point 0, 0, that's the only common point in both axes. So we've seen this already. I'm not going to spend a whole lot of time on it, but we're just going to practice plotting some points. So 5, 8. So I need to move over 5, 1, 2, 3, 4, 5, and then we go up. And then we get our point. And then B. So negative 5 halves 3. Okay, well, if I break these into halves, 1, 2, 3, 4, 5, and then I go up 3. 1, 2, 3. Negative 5.8, negative 3. Negative 5.8, so that's about right here. And then we go down. 4.5, negative 1. Now 5, 0, because one of those is zeros, I know it's going to be along one of the axes. In this instance, we go over 5, and it stays at 0, so that's going to be an x-intercept. And then 0, 5. It's going to be our y-intercept. Negative 7, 0 for F, or sorry, for G. H, 0, negative 9. So 0 for the x, now -9 for the y. So we're going to move down there. And then 0, 0 being the origin. Now another way to analyze this coordinate plane is that it's divided into quadrants. And any value or any point that's placed here, we would say in quadrant 1, and then we count it counterclockwise. So we count it starting going that way. So then this is quadrant 2, this is quadrant 3, this is quadrant 4. And so if I wanted to state what the quadrants are, I could say point A is in quadrant 1, point B is in quadrant 2, point C is in quadrant 3, and point D is in quadrant 4. Now, I know you're thinking, well, what about the values on the axes? You would just name it saying that it's on the axes. So in closing today's lesson, what did we learn today? We talked about the coordinate plane, and we talked about placing points. Now, what is the y value of an x-intercept? So if we were to imagine it, x-intercept is any value that's on the x-axis. So the y value is always going to be 0. And then what quadrant has a negative x value and a positive y value? So if we kind of draw a little quick sketch, so negative x value, positive y value, so this quadrant here, that's going to be quadrant number 2. If you have any other questions, please leave them in the comments.